Hello, AP scholars. Sorry I can't be here today. So I will just go forward with the slideshow the stuff we didn't get to finish off last class. And I apologize in advance if I am coughing and gross. So here we go. We're going to begin. There was one last thing about overriding and polymorphism that I wanted to talk about. And that is for our example classes. If I could just take you once again to the, I guess to say undergrad student. I'll zoom in here so you can see. You might want to follow along on your own copy of this that's on the website. So talking about undergrad students, for example, it could be the other one, and also student, which is of course a little bit longer. And the thing that I wanted to mention that I didn't have time last class, that's about this polymorphism concept, and really, it's really not about polymorphism. It's more about inheritance and what happens when you have a situation which isn't overriding. So, for example, undergrad extends student and overrides the calculate grade. Correct? Right? I'm pretty sure that's true. Yeah, there it is. There. Oh, that's calculate grade. So I just wanted to put forward the idea of what would happen if you did not in undergrad override calculate grade, and then from an undergrad student called calculate grade. So for example, imagine, I wish I could do this better, but I'm pressing madly slamming on the delete key. This is on a web browser, so I can't edit it. But imagine you had not overridden the calculate grade method in the subclass. And then say, for example, you had some kind of undergrad. Obviously, this won't compile because I don't have these classes actually implemented here, but undergrad student, or maybe I'll even make it a student. It doesn't really matter. You could do undergrad or student. Call them Steve equals new undergrad, whatever parameters you have to send there. I'm not too sure. But then imagine you said Steve dot calculate grade. And if this is a situation where you have overridden this method, then it will call the undergrad's version because that's polymorphism, right? It'll select the type of method that is associated with what Steve actually is, not what Steve is declared as. That's what polymorphism was all about. But imagine if you had not overridden calculate grade. So what happens? So that's what inheritance is all about. If you have not, then you go calculate grade. If you've not overridden it, then the undergrad objects inherit the superclasses calculate grade. So you can still do this. This is still perfectly fine. What calculation would go on here? Well, because undergrad extends student, it will inherit this calculate grade. So it will do this method. You don't actually get to see it in here because, that's what extends is all about. It's, it's not going to retype it or anything, but it does, as if you retyped it almost, it will get a copy of this method that all undergrad objects can call upon. If we override it, that's when polymorphism comes in, and then polymorphism will select which is the right one to run. And that, again, polymorphism is all about what is the actual object that's implemented here. It'll select that version as opposed to the type of variable that you have, or type of array, or whatever the situation has. Yeah? Yeah, are you feeling it? I hope so. This is going to be lots of questions about this as we go forward, I'm sure. Another example of the, if you're not overriding stuff, like there's actually a whole bunch of other examples that we can look at. So for example, set grade, get grade, I guess that's all, get test average. These are all methods that an undergrad student will inherit from its superclass. So you could do things like get grade. So I could say Steve dot get grade. Totally awesome to do. How can I do that? There's no method here in this class, the undergrad class, that is of that name. But it's because I extend student, I inherit all of the methods, even if they're private. But that's a bit of a long story, so I won't get into that just yet. I mean, it's not really a long story. The story was told on the PowerPoint slides. Pretty much, it's the same story as with the variables. So to keep this succinct, though, I want to keep the track moving. If you have some questions about that, please feel free to go onto the Discord, send them my way. Oh, I would love to like wake. I'm gonna go to bed after this, but I would love to wake up and just have like a bunch of questions I could answer on the Discord. You could put on the Facebook too. You could email me, whatever you like. I know this is kind of tricky stuff. Okay, so anyways, there's that. We're gonna move on now. I think we got to did the super keyword. And partially overridden methods, which is a fantastic name, but you know, it's nothing too fancy. But here comes the downcasting. Downcasting is this ugly syntax, and we're going to tie it into the object class in a little bit too. So I'm going to give an example after we do that. I introduced the idea last class just before the bell went. The idea is that you know, this kind of looks like a polymorphism situation, right? We're making a grad student in a student type variable. So it's all set up for some kind of like, you know, deciding which overridden method to run. And then we have a situation like this. So I have S is a student variable. It contains a grad student. And then I try to do get ID. And it fails. And the reason is because, and I guess just before I go further with this, you might wonder why would that fail? Isn't that how polymorphism works? But remember, polymorphism is about deciding which overridden. Let me go back to the, which overridden method to call. And in this case, whenever you have a downcasting situation, it's all about methods that aren't actually overridden. So let's go look and see. Grad students have an additional grad ID variable, and they have a method called getID, and although they do extend student, student has no such method. If you look through student, you will find there's no getID method. GetID is not overridden. It's a unique method inside of only grad student. So when you go to have a student variable, which we've seen the advantage of why you might do this. You have a grad student object inside. If you ever need to call anything that's specifically only in grad student and not in the superclass or any of the superclasses, then oh my gosh, you have to do downcasting. So I'll show you the syntax of what you need to do. So this is the downcasting thing. So if you have that situation and you want to do the getID, blam! This is what you got to do. This is a cast, just like we used to do casts from like double to int, for example, when we wanted to chop off the decimal for like, generating random integers or something. We're just casting S to a grad student object, and that's totally okay to do because it actually is a grad student object, right? We made a new grad student. And then we wrap the parentheses around it again so that this happens first. This takes precedence. And then the resulting object S is a grad student, so then we can call it getID. Ouch, right? That's kind of, ouch. That's a little bit tough syntax. It's one of the uglier pieces of syntax in Java. And that's saying something. So, yeah, there you go, downcasting. When do you need to do downcasting? So again, it's all about you're in some kind of situation where you have the variable or array or list or whatever it is that's of superclass type. The actual object you're working with is a subclass, and you need to call a method that is not overridden. Bam, that's it right there. Easy to get confused with situations where methods are overridden, and I totally understand if you get confused with that. And we'll have questions. There's a package you're going to get in a little bit. Maybe your teacher has already handed it out to you. They'll have lots of examples, or at least some examples of questions where you have to decide, do you downcast or not downcast? And please bring your questions next class. I hope I'll be healthy by then. I'm pretty sure. I've got a weekend to recover. Okay, downcasting. Okay, we're going to go on to the object class. Woo! Object class. It's actually a pretty amazing story, and we're going to get to see downcasting in it. We'll write a little bit of code to see what to do with downcasting as an example. But it turns out this object class thing is a secret superclass to all classes that you've ever written. Anytime you wrote a class, secretly it extends the object class. And that's where things like toString and equals exist. So anytime you wrote a toString method, you are actually overriding the toString method in the object class, which is where all the mechanisms for making that toString method work. I'm so excited to tell you this. It's like I couldn't tell you before because we didn't know about this extends stuff. But now that's kind of where the magic of toString happens. It's because there's a secret superclass. And anytime you use an object, it's using polymorphism to decide, oh, well, I guess we use this toString or that toString. And all the mechanisms for really making that work are sort of hidden away from you. But it turns out that you might actually want to use the object class. It's not just a secret thing, it's a thing you might want to use. Check this out. Imagine you had an object array. So this is an array of type object. It's called objects, right? What could you put into this? Well, remember, this is the super... Oh, I don't know what I just did. Oh, dear. Let's back it up. I've really bonkered it here. Scroll. We were just at the moment of an exciting moment. I don't know what I'm saying. I'm too excited. But here we're back. Imagine you had an array of type object. You could put anything you want in here that is an object. You could put a string in this array. You could put a fraction. You could put a list. You could put another array. You could put anything you wanted to in this. This is just an array of objects. And anything goes in here. And then there's not a lot of polymorphism going on because there's only two things that you can override. So you're going to probably have to use a lot of downcasting. Here's another example. Check this out. Here's a method, and its parameter receives a parameter of type object. So it could take anything. It could take strings. It could take arrays. It could do whatever you want to do, and it would be able to, you could code that to work. So let me just show you an example of maybe this in action. I'm just going to copy this. I'm going to go back here, and whatever, let's move this down. And imagine we did have this method here. And let's just think about what we could do with it. So maybe I wanted a method that could take a string or it could take an array. I don't know. This is just an example. So unfortunately, like obj is either a string or an array. So how do you can't just do dot substring or something. It might actually be a string, but you don't know if it's a string. Well, sorry, you can find out, but Java doesn't know right now. If you try to do this, it will fail. Why does it fail? Because this is not necessarily a string. Certainly not by type, and so we need to be able to downcast it or something in order to call this. So in order to do that, I have to make sure it's first a string. So here we go. Watch this. I can say, hey, if object, and then there's this cool keyword called instance of. It's gold. Wow, beautiful. Instance of obj. Oh, sorry, instead of string. Yeah, check this out. I can do this. I can check, hey, is this a string? If it is, the rest of this code inside of this if statement can treat it as if it's a string. I still can't do this, though. This is still not allowed because even though object or obj, whatever this is technically a string inside, assuming this if statement is running, right, because I just checked, then I still can't do this because substring isn't overridden. It's only something that's in the string class. So downcasting, this is where downcasting comes in. I can cast object to be a string, and then I can call substring from there. There you go. That's where downcasting comes from. Again, why do I need downcasting here? Because object doesn't have a substring method, even though string is a subclass of object. It's not overriding substring, right? So then I gotta do downcasting. There's another way to do this, by the way. This is just the way you see it a lot. But if you get tired of maybe you have a lot of stuff to do, like a long list of things. Here's another thing you can do. You can make a temporary variable. You could say string s equals, and then you could do the casting here. String obj. So if you do this, what you're doing is you're casting, downcasting technically here because object is being cast down to its subclass. And again, we can only do this because we first checked to make sure that object actually was a string. And then we're just going to store that casted thing in a new string variable called s. And now s is a string, and it's referring to the original string. It's a string by name as well. So then we can go s.substring. So you can do this downcasting on two separate lines as well. And then you can just refer to s for all the things you need to do, whatever, all the things. You can just do s. Saves a bit of time. Wow. There you go. And hey, guess what? You don't have to just deal with just strings. You can write other if statements to say, hey, if object is instance of, I can spell, of fraction, handle it this way. If object is instance of, you name it, whatever it is, integer. You could write a bunch of if statements to handle any kind of data you get sent in this crazy function. You can first make sure it's a particular kind of data, and then you can downcast it, and then work with it. Yeah. So object's actually pretty handy. It makes you can make really flexible methods with it, with very flexible parameters or very flexible lists or arrays, data structures, you name it. So the object class is pretty phenomenal for flexibility. Don't be scared of the object class, by the way. We're coming up with something else that's a little bit maybe scary, but don't be scared of it. I find a lot of times the AP exam will stick on just this object right here just to scare you. They'll throw it in as a parameter. And it might be a situation where they're trying to get you to demonstrate your knowledge of downcasting, but it also is most likely just there to be weird. And it might not even be part of the question. It's just an ancillary aspect of the multiple choice question where it just happens that a method has a parameter that is an object type, and it's not even interesting to the answer, but it's just there to be like, whoa, scare you. It's not thing to be scared of. It's just a superclass of everything, and it has two methods that can be overridden, and it has a lot of examples of downcasting, but otherwise that's it. It follows all the rules of all the stuff we've been talking about for the last little while. Okay, object class. There you go. Moving on to abstract classes. There's no abstract class. Looks like the scariest thing, right? Abstract is generally hard, or even the word looks like a fancy word. So abstract just means it's an idea, not something that's real. Abstract things are ideas. Justice, for example, is an abstract concept. Point to me in the world where there's a specific justice. It's only there because we had the idea and we try to implement it in systems. It's an idea. So abstract, or here's another example. What we talked about this last class. Mammal. Point to me somewhere in the world where there's something that's just a mammal and nothing else. Don't point to a tiger or a human or a whale. Those are, separate animals. There's no thing that's not also something else that's a mammal. A mammal is a group. It's a collection. It's an idea. There's no roaming mammal creature that is only a mammal and not something else. It's an idea. So sometimes we have those in our hierarchies. And you don't want, say we're making this zookeeper game and you wanted to have a bunch of tigers and bears and beavers. I don't know. I'm trying to think of mammal names. But you have a bunch of code shared between those things. And so you make this mammal class. But you don't want to accidentally make a mammal object because that doesn't make sense, right? It's a place to inherit from, but it's not a thing you want to create. So that's what an abstract class is for. Uh, Honestly, here is it. This is it. This is all you need to know really about abstract classes. Abstract class can't be instantiated. It cannot be instantiated. You can't go make an instance or an object of an abstract class. That is really all it does. This is like, in terms of the mechanics, the word abstract just prevents you from calling its constructor from the main method or from an outside place, other than through the super keyword, which we'll talk about in a minute. So yeah, you can't instantiate them. You cannot make it. It'll just not compile. You can only extend it. It's there for the purposes of inheritance, so that you can combine a bunch of common methods between various classes into a single superclass, and then you just don't want to instantiate it. That's all there is. And the questions will try to confuse you and make it seem like it's more than that. That's all it is. This is it. These two sentences is really the whole thing. I will mention, though, that even though you cannot instantiate it, you can have a constructor in an abstract class. That's totally legit. And the whole reason for that is for inheritance. So like, if you make a constructor in your subclass that extends this abstract class, it can use a super keyword to call the abstract class's constructor. But just because an abstract class can have a constructor does not mean you can construct it. It's just for inheritance. That's it. That's the whole story behind abstract classes. I find so many students will get worried about the abstract class, and I don't blame you if you do. Like, if you're like, oh, Mr. Pelche told me not to worry about it, but I feel confused, that's still understandable 100%. So please check out the questions today, experience it, remember this advice, and then see how it goes. And when you see the answers to the questions, you're like, oh yeah, it was true. It was just that. It was all it was. But you might need to go through the experience first. Okay, interfaces. Man, we're hitting a lot of topics. So here's a cool thing, interfaces. This is an example of an interface. It looks a lot like a class, right? This is not a method. This is sort of its own separate thing that you would create in a separate file. If I go over to I want to go over here. What we're doing is we're making interface, and if I go new class, I can choose instead interface. It's sort of an alternative to class. It's not something inside a class, it's its own separate thing. So I can make, what is this one called? Flying object. So I can say flying object. So check it out, it's an interface, and it gets like its own little, in BlueJ, its own little fancy header there. If you open it up, it's got a lot of junk in here. Let's get rid of the junk. What the heck is an interface? So an interface is kind of similar to a class, except that it's like a light version of a class, I guess. Here's an example of the kind of thing you would put into an interface. It is, check it out, just a name of a method. Here's a method's name. Here's another method's name. You don't put implementations, although I guess in Java 8 you can put implementations in these, but it's not really what it's not really its original design intention. What an interface is just a list of methods that you can guarantee are going to be in another class. So I'll just copy this over just so you can see what that would look like. Let's copy it over. I'm gonna put that in. Here we go. There's an interface. That's all it is. It's a list of methods. A list of methods. And what do you do with this list of methods? So this is sort of the next thing. Other classes, and notice that it's a class now. This is separate. Other classes can implement an interface. This is a new keyword, implements. It's similar to extend, except that there's no inheritance here. There's no inheriting. So I'll show you. Let's make this class. I would love to make this class right now. I'm gonna make a new class. It's gonna be called bird. I think. I don't know. Oh, it's called yeah, bird. I'm gonna make a bird, and in my bird class, we'll get rid of all this junk. Ba da ba 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 ba. Boom! All that junk is gone. Hard to delete. Okay, and we're gonna say implements flying object. Okay. So what's the value of doing this implements thing? So implements, the implements keyword, is like signing a contract promising Java that you will implement, or in other words, write code for, all the methods that are in this interface. So I have to, in addition to my constructor, which I won't implement, this is separate, you just want a constructor anyways, I have to make a void fly, sorry, and you would actually put the code in here, and I have to make a boolean is flying. I have to. If I say implements, it's like I'm promising Java, I promise, I solemnly swear that I will implement all of the methods that are listed in the interface. And if I do, it'll compile. If I don't, is flying. So actually, let me put in the public in here. Let's see. I might have to include public keywords because you're supposed to be, implementing public. Oh yeah, so I'm missing the return statement, but that's just because, I'll just return true. So check it out. So sorry, I guess we should include the public keyword because these are, supposed to be implementing a list of public methods to do. So yeah, there it is. This compiles. But if I did not, say I forgot to implement one of them, I tried to compile, I would get an error. I would get an error that says, essentially, it's pretty confusing error about abstract. It's not abstract and does not override abstract method is flying and flying object. So it's basically saying, hey, you broke your promise. You said you were going to implement everything that was in flying object. You didn't do it, so it doesn't compile. So that's great. Public boolean is flying. So does that make sense what implement is? Yeah? If you can't put it into a sentence right now, then rewind the video and listen to this again and see if you can sort of pick out what it is as opposed to me just saying it one more time. And the interface here allows you to sort of have other methods sign a contract to make sure they implement these methods. So what's the value of this? What's the point of doing this? So actually, I don't have a good slide for that. So I'll go and show you that you could make, say, once you have, let's go to this here. So if you have multiple classes that implement flying object, so if I have, like, say, the bird class implements it and the bat class implements it, then I can make a variable that is of the interface type. So I can make a flying object variable, call it flyer. And I could inside instantiate new bird, if, assuming that bird implements flying object. And I could, flyer 1 and 2 maybe, I could also implement new bat, assuming that bat implements flying object. I can do this. And you might be like, so what? Big deal. What's the difference between what we were doing before with superclass subclass? Because this looks like, bird could be a subclass of flying object, or bat could be a subclass of flying object. And that's true, that would work nicely. So why would you do an interface? What's the difference with an interface? So here's the difference. Sometimes there's nothing in common between birds and bats other than that they can fly, right? They're very different animals. They don't really need to inherit anything from a superclass. So interfaces are great for situations where you have two similar or two different dissimilar things that have no relationship with each other in terms of the code that you want to inherit. You don't want to inherit any methods or anything. You just want to put them in the same collection. So, bats and birds are different kinds of creatures. They don't really have a lot of code in common necessarily, except for that they both fly. And so you want to have those things there. They don't want to inherit anything. That's when an interface is fantastic. So this is great for making cross-hierarchical relationships. So, for example, there can be mammals that fly. There can be insects that fly. There can be, birds that fly. And you want to put them all in some kind of collection, maybe. But they don't inherit code. Like, there's other sort of situations. So that's a really good reason. Also, you can implement more than one thing. So unlike superclasses, where you can only extend a single superclass, you can implement many interfaces. So you can create these kind of cross-hierarchical connections that cut across your inheritance hierarchy tree. And by hierarchy, like if I scroll back to like this kind of situation here, this is like a hierarchy, right? You have, this is the top of your tree, and everything's kind of descended from it. But if you have things that connect, like employee and grad student, maybe, because maybe grad students are also have some sort of like relationship. Maybe they both get a paycheck or something. Like you could create an interface that makes them connected in some way for the payroll software. Maybe they don't inherit. Maybe they have very different kind of paycheck situations, so there's no code to inherit. So you can create that separate connection between the two by making them both implement gets paid interface or something like that. So you can cut across the hierarchies. Again, you can only extend one superclass, but you can implement many different interfaces. Honestly, man, this is a lot to wrap your head around. I feel like you're going to be like just swimming in confusion with interfaces. But it turns out they really are just this simple. This is all an interface is. It's a list of public methods. And almost always in an AP exam, all this is just a list of things for you to implement. Like you'll just look at this. It'll either be a list of things that you can implement or a list of methods that are guaranteed to be in something. Writing interfaces is never difficult because, look, you just have to get the name right and the type right. That's it. So if a question ever has an interface in it, it's almost always either a hint to give you information or it is a list of things for you to do. And it is confusing because interfaces are a little bit weird, a little bit different, so it is easy for you to panic when you see one. But soon you will come to find that they are your friends. They are like, you will love questions that have interfaces in them because it turns out they're very clue-oriented. They're rarely the challenging thing in the question. Although, if you don't know what an interface is, you will experience, this panic. What do I do with an interface? So, on that note, we got a lot of theory here. I just dumped so much downcasting, super, overriding. There's binding, polymorphism, overriding, superclass, subclass, inheritance. There's so much that we just went over. You need a chance to try it out. You need a chance to see it in action. And I'm going to give you, or your teacher, whoever is here for you today, is going to give you a package of questions now for you to go try. And they're going to be pretty hard. In addition to the questions, I've also photocopied a theory section. And I invite you to read it over. I really think it's a great thing to do just to read it over. You don't have to read over the entire thing, but as you get stuck on questions, you can go refer to the theory section as well. Because sometimes it takes reading and listening, multiple channels of this information to get into your system and for it to start making sense. So I hope that this is a good introduction. I'm sad that I can't be there to answer your questions today. So please do use the channels that we have, the Discord, the Facebook group, or email, whatever you want, and send me some questions. And either way, next class we'll do those questions, and I'll go over things that people were asking about. All right. Thank you so much, everybody. Have a great day.